Today we'll look at the Old Faithful dataset, which is a dataset based on a geyser in the National Park, Yellowstone National Park in Wyoming. It looks about like this. That's in 1948, and it's been analyzed over time quite thoroughly. For example, here's a paper from 1990 where they look at some data on the Old Faithful geyser. And today we'll take a look at the causal inference approach, and then we'll take a look specifically on a paper from 2009. If you go to causal-inference.org and on the resources tab, you will find a collection of papers, and today we'll take a look at the nonlinear causal discovery with additive noise models. So that's a paper by Hoyer in 2009. And there's a code that comes with it, so you can click on the link here. You will be directed to the MPI page on causal inference, and here on the selection list in 2009, this is actually 2008, there's a link to the code. Now we can download that, and we'll take a look at how we can run it on a Mac today. So let's just extract it, and we're left with this structure here. So we have a code folder, a data folder, a figure folder. Later, when everything's running, the figures will just be saved here. This is the data. There's 3 data sets for this paper. One of them is the geyser. So as we can see, here's the README, and here's the data set which we'll use. The code is a combination of MATLAB, C++, and Fortran, and it is quite a challenge to get it running, especially if you're not familiar with MATLAB. So let's just start at MATLAB and see where we can go from here. Okay, so when you got your MATLAB open, you want to go to your download of the additive noise model folder, and then go into code. Now we got the 3 folders here, the experiments, and then 2 other things, but we want to focus on the README now. So here's the README, we open it up, and here's the introduction, and then we can see that there's some stuff we still missing. So we need the GNU scientific library, which is also generally known as the GSL, and the Boost C++ library. Now, here are the instructions for Linux. In Mac, you want to install it a bit differently. For example, you can start with Homebrew and install with Homebrew. For example, just put that in Google, you get a link, and then you see here you can just download with Homebrew. So just download your Homebrew, and then you can select here different versions of Boost. The normal version should be sufficient. The same works for Homebrew GSL, and then you get the formula here as well. Okay, that's the broken page. There we go. So brew install GSL. Now when you've downloaded and installed these 2 libraries, you can skip this step for now, and then you have to edit the makefile before we can break. So before all of this can be compiled, we have to adjust the makefile to allow for proper compilation. Now we can just go straight ahead and see what happens when we run the makefile. Now let's just go to our additive noise model here. We're going to change directory. We have CD, and you can just on a Mac pull this over here. Now you get the path, and then let's list this here. So all you see is here, and let's go straight into a make command. So let's see. Now we see there's some forewarnings, but as a whole there's still an error that doesn't seem to get compiled. In fact, we can see that there's no such file or library for this max path. So if we go in here and take a look at the makefile, we can see that there's a compiler flag. So makefile really is just a more structured way to compile a whole lot of different flags and options. And in this case, the path to the max compilation program is just for Linux, and we need to adjust that. So that's fairly easy. We just go in here, we open up a new Finder window, we go to Applications, and then we find our MATLAB installation. And then we can just click on Show Package Contents, and then you want to go to the bin folder or the binary folder, and you can see here the executable. Now we can just get the path by going back to the terminal and just pulling this in here, and then we can just copy this from here. And this is the max executable you want to work with. So we just paste this over here, and now we save the make file, and now we go back and run this again. We can see that it can't find it now, but in this case it can find the GSL library. So this has already been installed, but it hasn't been linked properly. And there are different ways to do this, and today we'll go with a very direct way. So we'll just have to figure out where the library is, and if you install it with Homebrew, then you find it in user local celar, and we can take a look at the whole folder here, all kinds of different libraries, and then there's also the GSL. So we go into the GSL, and we see there's the 2.5 version, and then in the GSL we need the include folder, and then that's all we need. So we do pwd for the current path, and we can copy this, and then we can add it as an option to the let's see what this is about. We can add it to an option here. So what you want to write is dash capital I, and then just print the path from your paste board. Dash capital I again. These are the two different compilations that are taking place. One max for the independent tests with the hsig, and then for the test all DAGs we need the inclusion as well. Now if we save this here and we go back and run make, we can see that we're not actually in the additive noise model folder, so we need to go back with cd and go back to the code. So just pull this over here, then we run make, and then we see that in this case the boost library is missing. So in the same manner, we're just gonna go to user local celar, and then we also see here the boost library linked here. We just go into the boost library, that specific new version here, in the include folder, and then we see the boost, pwd for the path, copy the path, and then do the same procedure here, dash I, and then adding it there, dash I, and adding it here. And now we can run make again, but before that, let's go back to the additive noise model. There we go. And let's see what happens. It's building, and we can see here how the max file pops up on the left. Now these two max files are bridges between MATLAB and the C++ implementation, and they are necessary to run the old faithful example, which back then had been implemented in a very specific way. But now we can just go ahead and run the startup m script. This will go into the GPML folder, which is the folder that includes the Gaussian process regression. You can read that for yourself. And then it's honest, we're going to add these paths here. And then we've done this. We can go into the experiments folder here. We can go directly, open experiment old faithful, and we can run this. And then let's see here. It says it can find the geyser data. So let's go to experiments here. Let's see what happens here. There we go. This is the first, this is the second. And we can see how it runs the two models. So in the experiment for the old faithful, we can see that there's a forward model that's being tested, so the regression of x on y, I think, and then the backward model is y on x, and then checking which one makes more sense. Then we also get the p-values here, so fairly consistent with the paper. We can see a p-value of 5.7 to -1, or that's just 0.5. So if we go to the original paper here, we can see that for the old paper, we have a p-value supported of 0.5, and then for some reason we have here a p-value that's a bit differing to the one that's reported here, but then again we have a p-value for the forward, for the backward model. It's more in line with the observation, so we have 10 to minus 5, just a really, really small p-value, and a p-value here. They don't necessarily fit, I haven't figured out the reason why. This is the clean install, so it might be dependent on how the estimation procedure is worked, and this one is the installation with the max files that are not boosted up, but this is for another matter. And so this is the favor model, and we can see here that as a consequence, the current duration causes next interval of length. We accept that where the time interval between the current and the next interruption is a function of the duration of the current interruption by trajectory reverse model. And this is how the additive noise model here, the nonlinear additive noise model, gives us some kind of statement about the causal relation. The files and the figures are stored as an EPS. If you want a JPEG, you can just easily change this here to a JPEG, and then just run it again. And then we can go to the additive noise model here, the directory, we just go up and up to the figures directory, and then we see here the figures as they are also known in the paper.